All right, welcome to episode 1 of our IMI Insight podcast, where we're going to talk about our new service, IMI Insight. Today we have a few guests, a few people that are a part of the IMI Insight team. I'm Chris Barnhill. I'll be hosting today. I'm head of the Growth Hub for the Americas for IMI Critical Engineering. And today we have Jonathan Davis, Senior Manager of Inside Sales for IMI Critical Engineering and focusing on the IMI Insight sales. We have Dan Watson, Valve Doctor and Manager of New Product Development and heavily involved in the technology behind IMI Insight, and Ori Selzer, who's a Valve Doctor and Manager of Application Engineering and self-proclaimed Chief Technical Officer for IMI Insight. So thank you to our guests for joining us today. And if you don't mind, maybe just a quick introduction from each of you.
Yeah, so my name's Jonathan Davis, and as Chris mentioned, I'm a senior manager here for one of our inside sales teams, working in our aftermarket team, and been heavily involved in the IMI Insight project since it started. And I've been with IMI now for myself for about 10 years, initially starting on the IMI graduate program and working my way over to the team here in RSM. I'm happy to be on the podcast with you today, Chris.
Thank you, Jonathan. Dan?
Yeah, thank you, Chris. My name is Dan Watson. I've been with IMI and IMI CCI now for approaching 18 years. I've been a Valve Doctor for the past 8 years, and pretty much my entire career has been in new product development and field diagnostics, staying on the cutting edge of technology and creating the latest and greatest things for IMI CCI. And yeah, I'm happy to be here as well.
Thank you, Dan. Ori?
Thank you, Chris. Happy to be here. My name is Ori Selzer. I'm a Valve Doctor with IMI Critical Engineering and IMI CCI. I'm the manager of the application engineering team, and I've been with IMI for 21 years as of last week. And as far as supporting IMI Insight, this has been something I've been interested in for many years. So just happy that we're bringing this to market as IMI Insight and helping our customers solve their problems.
Awesome. Well, thank you all for joining us today. And as you can tell, a lot of experience in the room. And I think one thing that stood out there on this introduction is the term Valve Doctor. So can someone explain what an actual Valve Doctor is and kind of the process to become one?
Yeah, sure. I'll take that. So yeah, Valve Doctor is basically somebody that has a minimum of about 10 years experience. And it's a process within IMI where there's yearly KPIs and a development, almost like a university, exams, mentorships, and you progress through the process and through the program to different phases and stages while you're aspiring to become a Valve Doctor. It's as far as who the Valve Doctors are, I mean, that's kind of how you become one in the process. And as far as who they are, they're basically, the top experts, the technical experts within IMI Critical Engineering. And they're the people that help solve customer problems and deal with demanding engineering challenges that are out there for our customers. And they help diagnose these problems, hence the doctor analogy. So they're looking at the symptoms, diagnosing the problem, and then coming up with a cure, ultimately, whether that be in a hardware design or an operational change or a system evaluation. Yeah, so that's kind of who the Valve Doctors are. I mean, kind of a principal engineering team of the top technical talent in the company.
Awesome. Thanks for that. So we keep saying kind of IMI Insight, the name of the podcast. So I think maybe to kick things off, if we could kind of get an understanding of really what IMI Insight is, and really how was it created, and really why was it created?
Yeah, for sure. What is IMI Insight? Well, I think IMI Insight, I'd say it's the data analysis arm of IMI. So IMI provides a lot of hardware to many critical industries and applications. And what IMI Insight is it's this data analysis arm of IMI. And so we solve customer problems using physics-based algorithms with the customer's operating data at the core of every one of those calculations. And so for decades, IMI has been helping customers solve major problems and avoid failures at their facilities. And what IMI Insight does is it takes that knowledge, that experience, and that expertise from all those decades of solving problems, and it just makes it much more accessible to our customer base, much more targeted to real life operating data and real problems specific to your individual facility. So that's really the key to IMI Insight, is that it's making all of this accessible, but not in some general way, but more pinpoint focused to your operating data, your specific problems, and the issues at your facility.
Thanks for that, Ori. And is there a certain, and I know you and Dan and others have been thinking of this IMI Insight concept for probably many years, but at the end of the day, kind of how was it created? And I think you've answered kind of why it was created, but how was it created? Was it just a few of you guys or valve doctors in a room and said, hey, let's do it? Or what were some of the main drivers of creating IMI Insight?
Yeah, well, kind of as mentioned, we've always been focused on solving problems, solving our customers' problems. I mean, that was in the idea of valve doctors, as we discussed, and all of this. So as being positioned like that in the industry, we're in a unique place where we really get a good understanding of our customers' problems, and we get to see some trends occurring that maybe our customers don't see, because we're in each of those industries and applications, and we can see these trends coming. So ultimately, we're creating this tool to try to really help our customers avoid some of these problems that we've seen throughout the years. And it really became something where it was just, honestly, it's not that it was frustrating, but it was something where we were seeing problems occurring again and again and again, and we knew how to solve those problems, and yet the problems continued to happen. And so what IMI Insight does is it really allows us to try to get ahead of the problems, use customer data, use how they're operating our system to show them the data signatures are here, you need to change these things, or help a customer understand, if I keep doing what I'm doing, this could destroy my system in the future. Or maybe something isn't that bad. The other thing it could do is it could help identify, some operation that, okay, this maybe is okay, but maybe something over here needs to be changed. That's why it was really created. It was to ultimately stop these problems from happening, stop them before they start. That was the key.
Awesome. Thank you for that, Ori. I know IMI Insight and the whole process can be used in different types of facilities, different type of industries. And I know we've had some initial uses and successes around kind of combined cycle power plants. And I think you were alluding to some of those problems that we see. But what are some of the issues that we're seeing in combined cycle power plants, or just some common issues that are out in these facilities today?
Chris, that's an interesting question, and it's one we've really put to our customers, which really helped us kind of define Insight and get it to where it is today. A lot of our customers experiencing unplanned shutdowns, which is, the biggest cost to some of our customers when they have to bring the plant down outside of a planned outage schedule. Not only is that additional maintenance costs for them and, unusually high equipment ownership costs, but that's the major loss in revenue as well when the downtime is unplanned and it's an unexpected shutdown. And then as we started to dig deeper, we really found that a lot of it relates to steam pipe cracking. And that's really where we've been focusing sort of in the short term of Insight, is what can we do to help our customers when it comes to steam pipe failures, cracks, pipe ruptures. Those are some of the key issues that we've seen from our customers that they're really facing up to now. And I talk about the high cost in maintenance and the loss in revenue of the downtime, but these also pose really dangerous operating circumstances and can really impact plant and personnel safety. So that's been the real focus for us here. How can we help our customers, stop that crack before it starts, and really sort of dig into the data, help out with some analysis that shows how plants are operating. Can they be tweaked? Can we help with control logic? Do there need to be equipment changes? How can we really optimize that process of combining several pieces of equipment that are spraying cold water into hot steam and do it in an effective way, which is going to extend and maintain equipment health and allow customers to run their plant most efficiently.
Awesome. Thank you for that, Jonathan. I think it's, I don't want to say cool to see, but the fact that we see these kind of common problems at different facilities, regardless of location, and the fact that we're able to kind of identify that and then use the data that exists to help solve some of those problems or suggest some updates or system changes to really help prolong the life and safety of a facility is awesome to see. So we've kind of seen or heard now what IMI Insight is and kind of how it became what it is today. But maybe to get into a little more of the nitty gritty or the technical pieces of it, as it is kind of a software as a service type feature. What does IMI Insight do? And we've kind of answered this in some ways, but really, how does it work?
So within Insight, we use a suite of software tools to perform the analysis and the evaluation of our customers' plants. And the core of the tools ultimately is the experience and the knowledge that we have across our business inside of our top experts. And what we've done is we've tried to create a platform that allows us to integrate this experience and this knowledge that valve doctors around the world within IMI and others that are experts in their respective fields, how we could take that knowledge information and essentially capture it and make it accessible to much more people within IMI and also to our customers. We do this by creating algorithms and calculations that take the extensive knowledge we have for these various systems and analyzes the customer data in detail to look for examples of bad behavior or things that could harm the system, essentially looking for things that are invisible to users who don't have the experience designing and operating this type of equipment to the level that we do. Fundamentally, it is a data analysis tool, and we're kind of rapidly expanding the capabilities in the short term. So at the moment, the way that it works is we receive data from a customer, and the customer will send it to us in a hard format, and it gets uploaded and runs through all these automated calculations. And the data is displayed on dashboards along with the results of the calculations themselves. And we can share this via the internet, in person, however we want to, with a customer, or we can write reports and issue it out. But generally, that's the format of how the insight analysis works.
Yeah, as Dan was saying about how we're ingesting all this data. I mean, decades ago, this may have been done with like a crude spreadsheet or even, gosh, by hand with, a paper and pencil on a graph paper or something. But of course, with the advancements in, computers and data storage and all of that, today we can ingest and digest months of operating data at 5-second intervals. We run all these algorithms and calculations quickly, and we're identifying these data signatures. For example, in the combined cycle plant, we can quickly review, dozens of startup trends immediately and really fast see systematic behavior of control logic, of hardware. This is stuff that just was not feasible even in the near past, 10 years ago or something like that. But again, at the heart of all this, it's the physics-based calculations that are the heart of this. And they're directly linked to the problems and to the failures. So, I mean, of course, you can talk about AI and probabilities and predictions and digital twins and things. And there may be a place for that, coming along in the future. But ultimately, our software right now is still based in good old-fashioned Newtonian physics and forces and mechanisms that drive failures. And that's what we're identifying. And that's what we're helping our customers avoid.
Thank you both for that kind of explanation. And from my standpoint, that's a lot of that's over my head, but that's not too hard to do. So when you guys say data, we're collecting data, the plants have data. I guess what data is available or what type of data are we using? Is this something they have to implement, or is this data that already exists? And then at the end of the day, how easy is it to actually implement IMI Insight into a facility?
So fundamentally, the data that we want to look at is what customers are already collecting, because there's a lot of information that can be obtained by looking at the normal transducer values they have for pressures, temperatures, flow rates, valve positions, megawatt output, all the things that are installed in your typical plant. There are, of course, other things that would be nice to have that don't tend to exist, but those are not required to get kind of the bang for the buck for what we do. If there are problems that are a little more involved that are hard to really pinpoint with the existing sensors, then of course we could make recommendations to install others or potentially bring them in ourselves. So, but it's all of the data surrounding the systems in question, and we'll just use one of the common applications is turbine bypass. Turbine bypass is a steam valve and a water valve interacting and injecting water to control the outlet steam temperature. And so you've got the upstream and the downstream conditions on both of those systems, temperatures, pressures. You've got the signals going to the valves, the demand signal, the feedback signal, conditions in the condenser, mass flow rate values. A lot of times there will not be appropriate steam mass flow values, so we can calculate the steam mass flow rates based on valve position or a number of other ways. So ideally, we are granted access by the customer to get the data that we need. We'll work with customers to identify which tag numbers within their plants are important for us. And to address the second question about how easy can a customer implement, an insight study, what is the process to go through when we're looking at an insight study? It's actually very simple. If you sign up for an insight study, we tend to have a kickoff meeting where we discuss the particulars of the systems involved, because it's not always just one system being analyzed. It can be as simple as a single system on a single unit, or we could be analyzing multiple systems. Maybe we're looking at the HP to cold reheat and the hot reheat bypass to condenser and the interstage temperators. But whatever it may be, we would have a kickoff meeting to understand the scope. We would discuss what the problem history has been, what types of data are available, and sit down and actually look at, in some cases, upfront the P&ID drawings and find out what the tag numbers are, the information we need. This can be spread out over multiple meetings. If it's simple enough, it might be able to be handled in one. But ultimately, it's working directly with the customer to understand exactly what their problems are, or perhaps they don't have problems, but they just want reassurance that what they're doing is appropriate and they're not causing damage. And I mean, that's the fundamental process. It's relatively easy. We lead the charge. There's no mystery on the customer end. We'll provide everything that's needed for the customer to understand and ensure a smooth process.
Cool. I like how you said that. We take the hard part in this data that exists and make sense of it. I think is the outcome. And if there's changes needed or suggested changes, we can go that route. So I think all three of you appreciate the commentary to kind of understand what IMI Insight is, kind of how it can be used. I guess one question on my side would be, okay, a customer hears all this, they see all of this, maybe they have problems that they know of, maybe they have problems they don't know of yet. But why would a combined cycle power plant or a different type of facility, why should they use IMI Insight?
Thanks for that question. I think I see it in a couple ways there. I mean, first off, at the high level, I mean, you're talking about failures at your facility. So ultimately, you're talking about downtime, you're talking about profitability, those types of things come into play. So why might you want to use this system? Well, it's to protect your facility from forced shutdowns and unwanted downtime and profitability. But also, we've mentioned it a couple times already in this conversation. Cracking of steam pipes is one of those problems we're helping customers with. You're talking main steam, high pressure, high temperature, and personnel safety is a huge part of this, right? So ultimately, that's at the highest level, I think, is protecting your people, protecting your personnel from failures that could be really detrimental and a safety issue. So that's kind of the high level, this profitability, this safety issue, but more in the nuts and bolts side of why, you should use this. I mean, I think it just comes down to the fact it's always been the case maybe, but I feel now more than ever, people are just pressed for time. They're doing so many jobs, chasing down so many things and putting out fires left and right. I mean, I'm always amazed. I'll be sitting in an engineer's office at power plant or something, and I'm just amazed at their breadth of knowledge. I mean, while I'm there, somebody might come in and ask about an electric generator, and then another person comes in with a chemistry problem, and then I'm sitting there trying to talk to them about water spraying into steam, and this one person is kind of handling all of that stuff, and it's really impressive, But I think one of the things is that I think most of our customers would agree with this too, that was great, but they value specialization. They value the fact that they have to study all and understand all these things, but they really would like to lean on some of their key suppliers in some of these critical applications that are really crucial to the operation. And that's where they want the specialization. And that's what we bring with IMI Insight, is this specialized knowledge. We take it off your hands. I mean, at the end of the day, it's their data. They have access to this data. So yeah, they could sit and they could try to download it and plot it in some sort of program. And that might get them to this point of visualizing. And Dan said, maybe they could see something there, but do they know what to look for? And so do they have the expertise to really understand what they're seeing? So it's this, in the nuts and bolts of this, it's the time we save, it's the way we bring our expertise. That's the other reason why somebody might want to use IMI Insight, is for that reason right there.
Cool. Yeah, thanks. I think those are great reasons, and I think we've kind of covered again what IMI Insight is, kind of what it does, how it works, and really why it should be used. I guess one more final question for me on this side would be, when would IMI Insight be implemented? Is this something that is for early life power plants or facilities? Is it something that they have to be X amount of ages old, or I guess when is the right time to implement IMI Insight?
Yeah, Chris, I mean, really, there's no right answer to that question. Worked with a lot of customers from a lot of different scenarios. And, really what we would recommend is, thinking of this as like a health check. Ori and Dan have talked a bit about how much data we can analyze and some of the capabilities that we have. And, what this study is really trying to do is trying to find the things that you can't see in plain sight. So we've worked with a lot of customers, for instance, who have steam pipe cracks. They've done their high energy piping inspections, come across a crack in the field. They can repair it. They can get the plant back up and running. But what that doesn't do is address the root cause. It doesn't tell them why that crack happened in the first place. And it doesn't help them prevent the crack from occurring again. As we're working with our customers, we're trying to understand, which sort of category do they fit in terms of, is it a plant that's already seen a failure? And if you've seen steam pipe cracking, or if you've had any failures on any of your bypass or a temperator or steam conditioning systems, that would be somewhere we would immediately recommend. Let's come in, let's do one of these studies. Let's take a look at all that data, do the deep dive and try and figure out what's going on. But also, you mentioned new plants, existing plants, really it's all of the above. And we recommend if a customer is going to install a set of new equipment, new control valves, newer temperators, that's a great time to go in, take a check and do some balances to say, well, what's going on? Are we operating the most efficiently? This equipment it's quite expensive to purchase and install. And so we make the recommendation to do that check before you put your nice shiny new control valves in and, potentially do something that's maybe going to limit the operational life, or do something that's going to cause some damage to that equipment or to something downstream in the power plant. Also, if there's any changes to plant operation, several of our customers go through upgrades, increasing output capacity, any kind of change to the way the plant is run. If a plant is cycling now more than it used to be, if it was base loaded, any sort of major change in operation like that is going to be something that impacts the equipment that's being used. It's going to impact the operational data that we would capture. It's going to impact the fluid properties and steam pressures and temperatures that are going through this equipment. And that would be another time that we would recommend, let's take a stop, let's pull some of this data, let's have a look and see the before and the after, and see if there's any changes that need to be made to your equipment or to the way you're operating your system to get the most efficiency, operate in the way that's going to reduce the risk of failures downstream and lead to those unplanned outages and some of those safety related issues that we've been talking about.
Great. Hey, Jonathan, I appreciate that. And I think one of those points you brought up of some of these plants were built for a certain function, and over time they've changed either how often they're cycling, or maybe it's a whole different process, and maybe the equipment or the whole setup didn't get that kind of a initial review, and maybe it wasn't set up for what they're doing today. So I think that's a good point to add. So thanks for bringing that up. That's all I had for questions from episode 1. I think I will first want to thank our guests, Jonathan, Dan, and Ori, for all your, no pun intended, but all your insight on the service here from IMI Critical Engineering, IMI Insight. Want to thank our listeners for joining us on podcast episode 1, and look forward to you guys joining us in future episodes as well. I know you've kind of heard a lot about IMI Insight today, but if you want to learn more, have more questions, or just want to review some of the different materials that are out there, our website is go.imi-critical.com/insight, and that's INSYT. Or shoot us an email. We can start the conversation there, and that is insight, INSYT, at IMI-critical.com. So thanks again to our guests. Thanks for listening, and look forward to seeing you guys in the future. Thanks a lot.